G'day YouTube, welcome to my channel. It is the 16th of November 2023 and today we are going to be talking about Osmocom-BB again. This is about the third or fourth time I've attempted to record this video. I wasn't really happy with the previous attempts. I felt they got too bogged down with explaining what Osmocom-BB is exactly, and it had really long and boring disclaimers. So this time I'm going to exclude the introduction to Osmocom-BB since most of my viewers probably already know what it is. For those that don't know what Osmocom-BB is, you can browse to the official project wiki page here. And to learn more about the things it can do, please go and visit the Osmocom-BB playlist on my YouTube channel. Watch all these videos and read their descriptions to find out exactly what I'm showcasing in each of them. But to cut a very long story short, Osmocom-BB was significant back in the early 2010s because at the time, software-defined radios capable of capturing and decoding GSM data cost thousands of US dollars to purchase. And as for the disclaimer, let's keep it nice and simple by saying please do not use Osmocom-BB on a real 2G GSM network. Experiment with these software tools in a simulated lab environment like I have. Thank you. Two additional things you will need to know before we start is Osmocom-BB will not work on 3G, 4G or 5G networks. It is strictly for 2G GSM only. The second thing we need to know is that Osmocom-BB by itself will not allow you to decrypt private data from mobile network subscribers, such as telephone calls and SMS messages. Let's talk about the hardware required now. I shouldn't need to state the obvious here, but for the sake of completeness, I will say that we will need a working PC that has a minimum of one USB port. Probably the most important hardware tool we're going to need is an Osmocom-BB compatible mobile phone. Here is a list of the known working handsets on the project wiki webpage. This Motorola C117 was the first Calypso phone I acquired. Amazingly, I found it on eBay in the original box with the manual posted within Australia. My second Calypso phone is a Motorola C139. I sourced this from eBay in Germany. No original box or manual, just the phone and the charger. A second Calypso phone is not required for this tutorial. Another thing we will need is a Calypso cable, as I like to call them. That name doesn't Google very well, so a more relevant name could be an Osmocom-BB serial cable. It can either be a USB or old school RS-232 serial port, which terminates to a 2.5mm stereo audio jack. It's possible to construct one of these yourself, but I recommend purchasing this one from Sysmocom in Germany. I've got two of them and they work extremely well. Let's talk about the software required now. The operating system you will need to use Osmocom-BB on is Linux. The specific distribution I'm using that has Osmocom-BB pre-installed and working out of the box is DragonOS FocalX by SEMA Executor. The latest one will do just fine. And while we're on the topic of DragonOS, please go and check out Aaron's amazing channel where he also makes awesome how-to tutorial videos on Osmocom-BB. I need to make a minor correction to a statement I've made in the past. I've said previously that Osmocom-BB wouldn't work on virtualization hosts. But recently I managed to successfully use Osmocom-BB in a virtual machine. So I'm officially stating now that a physical machine or a virtualized instance of Linux can be used for running Osmocom-BB. The second piece of software we will need is Osmocom-BB itself. Compiling this and installing it from scratch in Linux is a monumental task in itself. So for the sake of simplicity, I always recommend just to use DragonOS FocalX. And finally, the last piece of software we will require is Wireshark. This will be used for viewing decoded GSM data in a human readable format and allowing us to analyze it. Optionally, we can use Wireshark's command line only variant called TShark, which is also pre-installed and working in DragonOS FocalX. You will certainly need some knowledge of basic Linux usage, such as running commands in the terminal window, command line interface, and how to navigate the Linux file system. The same can be said for GSM too. Some basic knowledge of how 2G communications systems work is not optional, but essential. So let's proceed to the practical segment of the video now. First, we will need to get our environment all set up and ready to go. So let's start by opening 3 separate terminal windows. You can open up new tabs in a single terminal window, but I find this configuration to be very unproductive and clunky. You can also add labels to each terminal window to easily identify which window is running what command. So on the hardware side now, I have my PC powered on and booted into DragonOS FocalX. My Calypso serial cable is plugged into a USB port on my PC. I have my Motorola C117 Calypso phone in a powered off state, and the 2.5mm audio jack is plugged into the phone's audio jack. This is the folder in DragonOS FocalX that contains the application binaries, firmware, and config files. So they are located in user source Osmocom-BB. So the first terminal window here is where we will run the command to download the Osmocom-BB firmware into our Calypso phone. I've had a few people ask me in the past whether or not you have to download and save the factory firmware first, like a kind of backup. The answer to this is no, because the Osmocom-BB custom firmware is not being written to the onboard flash memory, but rather it is being downloaded into the phone's RAM memory, and the phone is loading it from there instead of the flash. Before we begin with the firmware downloading process, I will run a command to confirm that my Calypso serial cable is being detected by Linux. Don't forget that when we are running sudo commands, this stands for super user do, you'll be prompted to enter your password. I have my Linux operating systems configured to never ask for a password when running super user commands. This can be considered dangerous, so do so at your own risk. So as we can see, my Calypso serial cable is being detected by Linux. So let's proceed with the tutorial. These Osmocom-BB commands are very long and complex, so I'll make sure to write them down in the description below so you guys can easily copy and paste them. I'm using the Compal E88 firmware in this tutorial, which is tested and working on both my Motorola C117 and C139 Calypso phones. Other models of Calypso phones require the E86 Compal firmware images, so please ensure that you do your research to confirm which firmware images are confirmed to work on your device. So we will just hit enter on this command, and it will appear as though nothing is happening. This is completely normal. The Osmocom binary is standing by for us to power on the Calypso phone. So after we hit the power button of the phone, we can see the application uploading the firmware. And after a short amount of time, we will begin to see some engineering information from our phone being printed in the terminal window. So far, so good. Now that the Calypso phone is successfully running the Osmocom-BB firmware, we can launch a variety of different tasks. We can launch a variety of different applications to achieve a number of tasks. I guess my viewers will want to jump straight into how to decode GSM with Osmocom-BB, but first, I will show you how to scan for 2G base stations. Because if we don't know what GSM cells are around us, we won't have anything to decode. So we will now turn our attention to the second terminal window now. This is where we will launch and run the cell log binary. This application will instruct the Calypso phone to scan each GSM ARFCN frequency looking for active 2G cells and output its findings to a text document on our PC in the home directory. Instead of waiting for a few minutes while cell log performs its scanning, and then we have to read the log file after, we can open up a third terminal window and utilize this command to print the discovered GSM base stations in the command line interface as we discover them. So we need to run both of these commands in quick succession of each other. Launch the cell log first, and then the tail command. And now we can kick back and wait while the Calypso phone and Osmocom-BB do their thing. I'm going to have a sip of beer. Sorry about that, guys. I'm back. Just had some minor technical difficulties. One of my GSM base station just crashed. So let's start again by running these two commands in quick succession of each other. And we can kick back for a second time and have a second sip of beer while we wait for the Osmocom-BB phone and cell log to do its thing. And after a little while, we can see two GSM-based transceiver stations appear in the third terminal window with various snippets of information about them. And most importantly, the ARFCN number, which we will need these values for decoding later on in the tutorial. So once we feel confident that we have found all of the 2G cells around us, we can send cell log the Control-C keyboard shortcut to quit the application. Now it's time to progress to the decoding phase of the tutorial. So now we will turn our attention to the second terminal window once again. This is where we will run the ccch_scan binary. This application will decode downlink data from a GSM base transceiver station and forward it to Wireshark for us to view and analyze. Because these commands are so long and complex, I'll copy and paste them into the terminal window. So one of my non-hopping 2G test cells is operating on a frequency of 925.2 MHz, which corresponds to an ARFCN value of 975. The A argument here is where you will specify the desired GSM cell that you want to receive. So you can refer back to this window to find that ARFCN numbers of 2G base stations in your local area. So I'll go ahead and press the enter key on that. The CCCH scan application window may or may not populate with information. It depends on how much traffic is flowing across this GSM cell at the time we are receiving it. In this case, I have a Samsung smartphone with a Sysmocom brand SIM inserted here to generate some traffic. In order to see what data is being decoded from the GSM cell, we need to utilize Wireshark. So we can proceed to open a fourth terminal window and run the following command. And it becomes immediately apparent to us that the top window pane of Wireshark is populating with decoded packets. So yeah, that's really, really cool. Because I'm not going to be digging deep into the traffic flowing across my 2G test cell, I can utilize Wireshark's command line variant, TShark. If you're the type of Linux user that hates graphical user interfaces and prefers to do everything in the terminal window, you'll probably prefer this method. So I'll go ahead and copy and paste the TShark command. And hit enter on that. And you can see the decoded GSM data is being printed neatly in the terminal for us. Okay, moving on to the next step in the tutorial now. This is probably my favorite feature, the most advanced program in the Osmocom-BB software suite, the mobile application. This binary is a full-blown software-only implementation of a mobile phone. Yes, you heard that correctly. Typically, all the cellular capabilities and functionality of a 2G mobile phone are handled by the dedicated baseband processor chip. Osmocom-BB's mobile app bypasses this physical GSM hardware on the phone and implements it entirely in software running on the PC side. Honestly, I'm not doing this application any justice by trying to explain it to you. It is a really, really incredible and amazing feature, and I'll show you why I love it so much. Just before we get started, I want to mention that you will need a working SIM card with a valid subscription from the cellular network operator that you want to test Osmocom-BB's mobile app on. If I were you, I wouldn't use the mobile application on a real GSM network anyway. Because my Motorola C117 Calypso phone has a Sysmocom brand SIM card inserted, it is able to interact with the GSM base station in my lab environment. So with all that being said, let's proceed to the tutorial. We'll now turn our attention to the second terminal window once again. And this time we will type in or copy and paste the following command. Okay, before we get started with this section, it is noteworthy to mention that 2G base stations running on software-defined radios can be very janky at the best of times, and they just often stop working. Sometimes they devolve into a state where they just do not function at all. So I'll try my best to show you the features of the mobile application, but ultimately we're at the behest of the demo gods and janky SDR-based GSM cells. If it doesn't work in a reasonable amount of time, I may pause the video to do some troubleshooting, and if I just can't get it fixed, I'll just wrap up the video. So here we go. So I'll just hit the enter key on the mobile app command now. And we should see the mobile application launching in the terminal windows, and it should begin to populate with a few various tidbits of information. And as we can see here, the mobile application has advised us that there is a telnet server available on our system loopback address on port 4247. So in this third terminal window here is where we'll establish the telnet connection. This is how we will control the mobile application by inputting commands, and we can ask it nicely to do various tasks, and it will output its responses in the telnet server for us. So we will type this telnet command in, or we can just copy and paste it directly from the second terminal window and hit enter on that. And now we can see that we have successfully logged into the mobile application telnet server. But it appears as though nothing is happening, right? This is completely normal. Don't worry, I know how to fix this. The configuration file shipped with DragonOS FocalX has the mobile phone's radio hardware switched off by default, similar to a flight mode feature of modern smartphones. And we can confirm this is the case by typing the following command and sending it to Osmocom-BB's mobile app. And we can see that MS1 is administratively down. MS is an acronym for mobile station in GSM engineering speak. So to rectify this, we will need to configure it to switch on our mobile phone's radio hardware and subsequently turn off this virtual flight mode. There's a few short commands we need to run, but there's quite a few of them. So I'll display them largely on the screen for you guys to easily follow along with me and without squinting at the tiny command line text. So after you've successfully logged into the telnet server, like we already have, input each of these commands exactly as they are shown on the screen and hit enter like so. The first one is EN, which stands for enable. The second command is conft. The third command is ms1. The fourth command is no shut. The fifth command is write, exit, and then exit one more time. And we can immediately observe that all three of our terminal windows have come to life, displaying vast amounts of messages and information in them, signaling that we have enabled our mobile phone's radio. And the Osmocom-BB mobile application has attached to the 2G mobile phone and GSM base transceiver station. So yeah, that's really cool. So there's various things you can do with this application to interact with the base station or another mobile phone on the same network. So I'll send the list command to show us all of the available options. And I've handpicked a couple of useful functions to showcase for this demo. So we simply type list, and we can see all the configurable options we can send to the phone. So the first one I'll showcase is the following: show ms1. This will show us useful information about the mobile phone. The second one is show sub1. This will show us helpful information about the connection to the base station, like the TIMSI value and location information. The third command is show cell 1. This shows us interesting information about the GSM cell that we are currently connected to. So, if everything goes to plan, I will proceed to show you how it is possible to send SMS messages to another subscriber's mobile phone on the same network using the telnet interface. This is a very, very nice feature indeed, and I will type the following command. with the phone number of the target subscriber I want to send the SMS to, and we should see and hear an SMS notification on my Samsung smartphone too. So I'll copy and paste this command into the telnet interface and hit enter. And we can see that I have successfully received a text message on my Samsung from the Osmocom-BB mobile app. That's really, really cool, man. And I can also send messages to the Osmocom-BB from the Samsung phone also. So I'll have a pre-typed response already typed, and I'll hit send on my Samsung. And after a short amount of time, we should see the reply SMS printed in the telnet server window. So yeah, that's really, really cool. It shows up a few times, 3 or 4 times. It'll repeat itself, which is completely normal. But wait, it gets even better now. We can even make phone calls from the mobile application, purely from the telnet server command line interface. So I'll copy and paste this command and paste it into the telnet interface. And I will hit enter on that. Oops, I think I've got the number incorrect. Sorry, it should be 42. And with any luck, we should get a phone call from the mobile application to my Samsung. So I'll just hit enter on that. And very shortly, we can hear my Samsung's ring alert tone. And using the following command, call one hang up, I can terminate the call. But yeah, that's really, really cool. It's not easy to showcase telephone calls due to the irritating echoing, but believe me, if I answer the call like normal, a two-way voice call is established in the exact manner that a real 2G mobile phone would if a call was taking place. The only difference is the call is taking place in software only running on the PC side, not from the onboard baseband processor of the Calypso phone. Mind blown. What an impressive feature. So what we might do, this is not in my script here, but what we might do is try to initiate a phone call from the Samsung to the Osmocom-BB phone, and then I'll answer it and then attempt to show you the audio, successful audio. So I'll just proceed to call the Osmocom-BB phone. And we can see in the terminal window, I'm receiving a call. So I'll write call one answer. And then I'll put my Samsung on speakerphone. And hopefully you should hear echoing audio coming from my Samsung, which is being transmitted through my Yate BTS base station from my Osmocom-BB phone. So yeah, that is really, really cool. And I'll just proceed to terminate the call from the command line interface. So yeah, that's a really, really fun overview of Osmocom-BB's mobile application. There's one more feature that I want to show you, which I think is pretty cool. And it's the ability to power down the SIM card and effectively disconnect it from the 2G base station while the phone is still powered on. So I'll type this command, sim remove 1, and hit enter on that. And we can see that the mobile phone has dropped the connection to the base station. To power up the SIM card again and reconnect to the base station, we can type the following command. SIM reader 1 and hit enter. And after a while, hopefully we can see that the mobile application is reconnecting the Osmocom-BB phone back to my cell. So yeah, that's really, really cool. Obviously there's a multitude of other functionalities that I'm yet to experiment with and learn about, but this demonstration has covered the features that my viewers will probably care most about. We can hit Control-C keyboard shortcut to quit the mobile application, which will subsequently terminate the telnet session also. Quitting the Osmocom-BB applications and closing the terminal window will not power off the Calypso phone. This has to be done manually by holding the on-off button until you see the display and backlights power off. If you're using a Osmocom-BB phone that doesn't have backlights and a working display, such as my Motorola C139, you can safely pull the battery out to manually power it off. And next time you power on the phone, the factory firmware will load perfectly fine, like nothing happened. So yeah, that's pretty cool. I was going to try and jam all the Osmocom-BB tutorials into a single video, but I think this one has overstayed its welcome already. So this installment will be part 1. In the second part, we will be on the subject of the infamous burst_IND branch of Osmocom-BB, which is the GSM sniffing orientated variant of the aforementioned software toolset. So yeah, I hope you guys all enjoyed this video. Thanks very much for watching. Bye.